2.2 is on solving systems by a method called substitution. When you solve by substitution, your first step is to look at the system and determine whether or not you have an isolated variable. Isolated means that the variable is all by itself. So notice how in the first equation I have a y that equals negative 4x plus 14. That means the y is isolated, which enables me to take this whole thing that I've circled and substitute it into the second equation. So the second equation is going to become x minus 2, and instead of copying down a y right here, I'm going to put parentheses, and I'm going to substitute everything from the top equation in place of that y. So I get negative 4x plus 14. Close parentheses, copy down, equals 8. Now I have a long equation that I can solve. At least they both have x's in them. There's only an x variable, so I can actually solve it. So I start by distributing the 2. That's my first step. So I'm going to copy down x minus 2 parenthesis negative 4, because I need to do negative 2 times negative 4, plus negative 2 times the 14. Copies down, equals 8. And now I can simplify the multiplication. So I'm going to have x, and then negative 2 and negative 4x. Negative 2 and negative 4 become plus 8x. A negative times a negative is a positive. And then negative 2 times 14 becomes minus 28. Copies down the equals 8. After I distribute and simplify, I need to add my like terms together. X plus 8x is 9x. Copy down the 28 equals 8. Now I have a two-step equation that I can solve to get x. So I add 28 to both sides. And 8 plus 28 gives me 36. So on the right-hand side, I have 36, and on the left-hand side, I have 9x. Okay, my last step is to divide by 9, and I get x equals 4. Now, am I done with the equation? No. When I solve a system, I'm looking for a coordinate for my answer. That means an x comma y. I found the x, which is 4, but now I need to figure out what the y equals. Wait, if you look back up at the equation, we know that y equals negative 4x plus 14. Well, if x is 4, then we can plug in a 4 where the x goes to solve for y. So I get negative 4 times 4 instead of negative 4 times x. Negative 4 times 4 is negative 16 plus 14 when I finish writing down the equation. So I'm left with y equals negative 16 plus 14. Negative 16 plus 14 is negative 2. And that's what y equals. That's the second coordinate, or the second number in my ordered pair. My final answer is 4 comma negative 2. And here's the second example for 8.02. Notice how I do not have an isolated variable. In the first problem, it was set up very nicely so that I had y equals, and then I could take that and plug it in. Here I do not have that, so I have to manipulate one of the equations to make it have an isolated variable. Look for a variable that has a coefficient of 1. Notice how you have 1x right here. What that would cause me to do is take the first equation, x minus 5y equals negative 3, and solve for x to get x by itself. So I'd add 5y to both sides to give me x equals negative 3 plus 5y. You don't actually combine those two numbers because this isn't a like term. -3 does not have a y. So now I know that x equals -3 plus 5y. And I can take that and plug it into the other equation now that I have a variable isolated. So in the second equation, I'm going to copy it down over here. I'm going to have -3, and instead of the x that should go right there, I'm going to take what x equals in the first equation. So I have parenthesis -3 plus 5y, close parenthesis, and then I finish copying down the original equation. Plus 15y equals 9. Now I can solve this equation. So I distribute the -3 so that I have -3 times -3 plus -3 times 5y. So it's this times this, and then this times this. Copy down the plus 15y equals 9. Now I simplify. -3 and -3 is a positive 9. -3 and a 5 is -15, and the y stays after it. Copy down. Plus 15y equals 9. After distributing and then simplifying, now I add like terms. I have -15y plus 15y. Those cancel and equal 0y, and I'm left with 9 equals 9. And you might say, uh-oh, where'd your variables go? My variable disappeared. When that happens, you have a special case for a system. A system can have one solution, no solutions, or many solutions. Many solutions is when the lines are coincident with each other. Remember, they're right on top of each other. That's from Unit 8, Lesson 1. If you're solving algebraically like this and you end up with disappearing variables and a true statement, 9 equals 9, that is a true statement. That means that we are going to have infinite solutions. You don't have to keep solving because it means that any combination is going to work for this system. And last, here's example 3. I look at my system and I notice that I have y equals again. Yes, this makes me want to throw a party. I already have an isolated variable. That means that I can automatically take whatever y equals, -5x plus 10, plug it in for y to the other equation. So I end up with, in the second equation, 5x plus, and then instead of y, I'm going to insert -5x plus 10. Copy down the equals 3 to finish the equation. Okay, I don't have a number outside my parentheses to distribute, so that saves me some time too. I can move right away to getting rid of the parentheses so I can keep solving. I get rid of the parentheses and I have 5x minus 5x plus 10 equals 3. I can go on to adding like terms. My like terms are the 5x and the 5x. So I have 5x minus 5x. Again, those get eliminated. They equal 0. And what I'm left with in the equation is 10 equals 3. Now, this is not a true statement. This is a false statement. 10 never equals 3. That's not true. When you're solving an equation and the variables disappear, just like they did in example 2, but in this one I have a false statement. In example 2, I had a true statement. When you are solving, the variables disappear and you get a false statement. That means that your answer is no solution. You don't have any more work to do. That's your answer. There's no solution. It means that these two lines, if you graphed them, would be parallel to one another. They do not cross, so they do not have a solution. So just to review, example 1, you had intersecting lines. You had a coordinate point where they crossed at, an x equals and a y equals. Example 2, The variables disappeared. You had a true statement. You had infinite solutions. Example 3. You are going to have parallel lines because you were solving, got a false statement, and that meant no solution.